Hello, Ali. Hello, Mike.
Hello.
Hi, Ali. Hi, Caio.
Hi.
Thank you for joining us.
Thank you.
So, are you an iOS developer?
Yes, I am.
For how long?
For about maybe 6 years now.
6 years. Awesome.
Yeah.
How can we help you?
Well, I want to know how to think about unit testing, because usually I write code and I ship apps, but I don't write the test before the modules. So, how to if I have already an existing project, how to add unit test to it and how to sync, how to approach and like write a test for a separated modules, how to do it.
Okay, so you're not writing tests at the moment.
No, not in the current project I'm working on. No.
So not even after the fact, after writing the code? Because there's two ways where you write the test before, like the test
Yeah,
first, which is the way
yeah,
we recommend,
yeah,
or you write the test after. Or you don't write
yeah.
the test at all.
No, for the project I'm working on right now, no. I know the TDD approach and watching the course, but for how can I say it, for the real life situation I'm in, I already have a project, but there is no unit test at all. So I'm not sure how the best way to approach this.
Okay. Yeah.
Okay, so if you have an existing project without tests, what to do?
Yeah.
Well, new code that you write, you can start with a test, right? When you write a new code with the things you're learning in the program.
If the modules are separated, yes, we can approach it. We can write the test first. But in the real life situation I'm in, all the things are coupled right now.
Okay.
Yeah.
But what is coupled that prevents you from testing? Can you give us an example?
For example, the view controllers hold very all the business logic, like 90%, and
Okay.
the navigation modules are in the view controller as well. The only thing I think is separated is the models, which I'm not sure how to test the models.
Okay.
I'm not sure if it should be tested.
Okay.
So you have a view controller?
Yeah.
A view controller. Import UI kit. It does a bunch of things, not just controlling the view. It also has business logics, and then it kind of mixes view logic with business logic, and then when you have to test, you need to deal with framework details like loading views and etc. So what you could do at this point, if you have this view controller, is write some integration tests with your view controllers. So testing the logic through the view controllers.
Okay.
Right, just as a starting point.
Okay.
And you said that the view controllers would make even like API requests, network requests.
Yeah. Everything in the view controller right now.
Okay, and it's hard to test because you cannot replace the network stack.
Yeah. What if I started the project from scratch? What I think I could do is separate this and write it in the NBVM design patterns, which is what I did, and how this is how I write projects for about like 2 years now.
Mhm.
And I have this template project. I shared the link of it, but I think the best way to be able even to write any kind of unit test is to separate the modules at first and somehow decouple the view controller part by part.
Yeah, absolutely. This makes it testable. This makes your components testable, decoupling, their dependencies. And as you're going to learn in the course, using dependency injection techniques like initializer injection, for example, this is going to help you to, it's going to facilitate the whole testing process.
Yeah.
For example, if you have here in the view did load, let's say you get a network stack singleton and you make a request like get user, for example, right? This is going to make the test hard. It will be the code hard to test now.
Yeah.
Because you can only test this code now by actually making a network request. Right? Because you're accessing the concrete implementation of the network stack directly, and not just that, but also accessing the shared instance. So you're locating the instance that will make the request, which makes it impossible to replace that instance during tests. Right? So this is something you should avoid. A simple way when you're dealing with legacy code that is making calls to a singleton like this, still use the singleton, but make it injectable somehow. For example, property injection. Make it do something like this. Create this class here. Let shared like this.
Yeah, just under Git.
Make sense?
Yeah.
Here you make a call, for example, to the network request, the network instance. Now during tests, you can inject, for example, a subclass of the network stack to be a mock. And then you don't need to make network requests.
Yes, the real request.
Right? You can pretend to make a network request during tests. And again, this is not ideal still. This is not a good design, but it makes your code more testable. So when dealing with legacy code, sometimes you need to make the code worse before it can get better.
Yeah.
That's the trick. Don't be afraid of breaking some rules just to make the code testable, because then when you have the test in place, then you are free to change the design and improve and make the code the way you wanted it to be.
Yeah.
Right? So make some ugly changes in the beginning just to enable testability. And then with the tests in place, you can clean up the code. For example, sometimes even what you can do here, if it's the simplest way to do, is to make this static var static let.
Mm-hmm.
Yeah. I heard I watched the session about the difference between the singleton and the property injection and the composition.
Yeah, and again, this is not an ideal thing to do, but when dealing with legacy code, sometimes you need to make some decisions to enable that testability. And with the test in place, you can then fix the design and start using proper dependency injection patterns.
Yeah.
And then at some point, when you clean up the code, you can even eliminate the network stack from the view controller. Until you get there, it's one step at a time. So what I recommend you do, go through the lectures, implement the project as you see there. Also do the challenges. Do not skip the challenges. They are important.
Okay.
Because they're going to test your skills regarding the modularity you want to achieve. Because just using MVVM is not going to solve this problem, because what starts happening is that you have the same problem. You're just going to move the problem somewhere else.
Yeah, to the view model. Yeah.
And the network stack is going to be here. You're just moving the problem under the carpet,
Yeah.
And then you're gonna have a method here. View did load.
Yeah. Yeah.
And then you have more code doing exactly the same and having the same problem. So
Yeah, I see.
MVVM alone doesn't solve it.
Yeah, I see this in a lot of code bases. You just removed the code from the view controller. You didn't do anything. Yeah.
Yes.
Yeah.
Yeah, so the idea is to really think about the design in a way that not just enables the stability, but also makes the code easier to maintain. Develop, maintain, reuse, replace, depending on the needs of the project. Some projects needs more reusability, some projects don't. Some projects needs to be deployed in many platforms, not just iOS. So then you need to, think of a design that will enable you to achieve the business goals, right?
Okay.
And dealing with legacy code, there are techniques to deal with that. There's a book called Working Effectively with Legacy
Yeah.
Code.
I heard
They
of it.
provide a bunch of techniques as well. And some of them it's gonna make your code uglier at some point to then make it cleaner.
Yeah.
Like making a singleton be mutable, the singleton instance, so then you can inject during tests, you can just replace the instance with a mock.
Yeah.
So let's say here in the setup, you can say network stack dot shared equals mock network stack. Now, everywhere in your code base, they access that singleton instance will be using a mock in the test target. You just have to remember in the teardown to undo that change.
Yeah. Okay.
Otherwise, this test may affect the result of other tests. Something like this. To undo, if you do something in the setup, you need to undo it in teardown, depending on what you want to achieve.
You also mentioned, Ali, that you have trouble thinking about unit testing. Is this something like you mean about the structure of a test, how a unit test should be structured?
Yeah, but it's like how for example, if I have like a feature, because unit tests are written differently for each modules.
Mm-hmm.
It's like, what is the best way to think about like the problem to test it? Maybe like drive scenarios, like the good case and the bad case,
Yeah.
like in the push or something like that, or write down what I want to achieve, or what is the goals of this feature and what it should be achieved, and start like writing small functions that
That's it.
that does it.
Yeah, exactly.
Okay.
These are the ways that, yeah. But I think we can demonstrate here like how, for example, how this example with a view controller and the network stack could work.
Yeah.
Right. With the we can structure the test in a arrange, act, assert fashion, for example, as we go through the course.
So let's see anatomy of a test.
Yeah.
Using XCTest framework that's provided by Apple, right? You subclass the test case class. You need to create your tests as methods of your class, and it needs to start with the name test. If you start with test, the framework will identify it as a test. You even get the arrow here where you can run this test. If you remove it, there it's gone. It means this is not a test anymore, just any method. If it's a test, you start with test, and then you can enter whatever name you want here.
Mm-hmm.
Test view did load, for example. So some convention says like you start with test because you have to, and then you say the method you are invoking, the method you are testing, and the behavior you expect. This is one way you can name your tests, for example. So view did load, fires network request, for example.
Yeah.
Right? And then inside the test, again, it's just a method. You can do it in any way you want, but there are standards to make your test more readable. And there is the act, arrange, assert.
Oh, it's arrange. No, it's arrange act, right? Like act is
yes, arrange.
Yeah.
AAA.
Yeah.
AAA. Arrange, act, assert.
That's right. Yeah.
So arrange, here you create the properties, you set up the initial state here. So let's say we are testing view controller. You did load. So we can create our instance here. We can call it like the view controller equals view controller.
Mm-hmm.
Now act. We need to perform some action. View controller dot load view if needed. That will trigger view did load. Then assert. Then you assert the behavior that should have happened. Make sense? In this case, yeah. Network should have called fired request, let's say. Here we can say network request. We need a network stack. We need to assert XCT assert equal network stack dot fired request is true. Something like this.
Yeah.
Can you see that now we have two instances that we created here? And as a reader of the test, I don't know what is actually the object under test here. What is actually the type under test? And
yes.
There's another standard of calling this instance, which is SUT.
System under test.
Yeah, which is the system under test. Just call it SUT. It's a standard. So when you look at a test, you know what is the system under test. What is the object we are actually testing here? Some people call it object.
Yeah.
Under test. No, whatever. You're gonna agree on a name with your team, and that's fine. You're gonna agree also how to call your tests. All of this needs to be documented somewhere, so everyone in the team follows the same pattern.
Yeah.
So another way, not another way, but another name to the arrange act assert is given when then. So given some instances, some initial state, when some action occurs, then I expect a change in the state of the system. And here you create the assertions. Of course, we don't need the comments here. At some point, this becomes second nature. If everyone in the team follows the same pattern, the same standard, then you have tests that are very readable. When you're reading the test, you check here, what am I testing? The view did load, fires network request. Okay, let's see the arrangement here. Create a network stack and the system under test here, which is the view controller. Then when we load the view, the network should have fired the request.
Yeah.
Make sense?
Yeah, makes sense.
So here we create the dependencies, we compose them. For example, the SUT here needs to have an access to this network stack, right? So it could be injected. So we can have a convenience initializer for the network stack. We remove this view model. Create a private var network stack. Init. Like this.
Mm-hmm.
Cool?
Yeah, cool.
So let's run the test. Whoops,
It's
self.
Yep.
Let's see. That's failed
Okay.
because the method fired request was not called. Okay, so now in view did load, we need to call this method in the network stack. Or something like start request. Just an example.
Mhm.
Let's say here, our network stack will have a function, start request. It does nothing, but our mock network stack will override it. And just set this to true. Instead of actually making a request, we just capture what happened. Let's run the test. Now it's passing, right? And you can do this with legacy code as well. Exactly the same. You instantiate, all the dependencies, you arrange the system under test, you perform an action, and you test the side effects or you test the result.
Yeah.
And that's how you can start testing legacy code as well. Even when you're using like mock network stacks and so on, even if there's a singleton somewhere.
Yeah.
Absolutely. Yeah.
And at some point you can get rid of this network stack in mocks as well, because if your controller should probably not talk to network objects
Yeah.
and requests. And that's how you can deal with legacy code as well.
Yeah, I see. Okay.
Yeah, and you see how you form your hypothesis in the beginning, like what I want to happen here. Like you need to know that. And when you do, right, and you write down your scenarios, as you said, maybe in a list,
Yeah.
you can start translating them into tests, and start testing the behavior that you want.
Yeah.
So I know that maybe, like massive view controllers or massive classes in general, seem daunting to start testing, but this is exactly how you do it. Like you break things down in small chunks, start with simple assumptions, like, okay, I want this to fire a request when, the view loads. Because what's going to happen most probably is like inside the completion of that request, you're going to have a bunch of code there, and other stuff being called. So that complicates things. But you start simple and gradually. And whilst you're doing that, you also exercise your unit testing muscle.
Yeah.
So yeah.
Yeah.
So the whole process becomes much easier. But again, practice is key here. Like these things are very hard to grasp, and practice is what makes it easier.
Yeah, I see.
Yeah, for example, if your start request here has a completion block, right? Because it's asynchronous. And let's say it returns the title, a string. We're loading the title for the view controller. Just an example. Then just checking that the request was fired is not enough. You want to check that actually when the request completed, you set the title of the view controller, right? So you can transform, instead of using a mock, you could use a stub. So networks stub, for example. And then you say like title. Title is whatever, any string. So then you have a way in the test of pretending that the request completed with a given title. So you can create a stub here. You can arrange that stub and say the title should be a title. And you expect after view did load, the view controller now title should be the one loaded by the network stack. Like this, for example, after this request completes, you should have set the view controller title to whatever was returned by the request. What is wrong here?
There's an extra brace on line 28.
Here we get the title from the test. It should fail because it's new.
Mm-hmm.
So now we can set here the self.title equals title. We're just testing this synchronously without actually making an API request, without adding timers to the test side, because we are replacing the network stack with a stub that provides a canned result here.
Yeah. And again, all this, you're going to see all this in the program, in detail, and the differences between mocks, stub, spies, all that.
Fakes, they're
Fakes, yeah.
There are techniques you can use to start testing your code, right? And you need to learn those techniques. And to start mastering, become a master in testing, you need to go through this loop. You need to learn concepts, like we're showing you here, some concepts like mocks, stubs, the patterns for naming, for arranging, acting, asserting, and so on. You need to learn those concepts. Then you need to see examples. Like you're going to see a bunch of examples there in the program. But ultimately, you need to practice. Practice a lot and repeat this. The more you repeat this cycle, the better you will become. If you keep repeating this, you're going to become a black belt in testing.
Absolutely.
That's the secret. The secret is to go through this loop repeatedly, continuously.
Exactly. More time spent.
Many techniques, and you become better by practicing. That's the secret.
Yep.
The $1 billion secret. Because just watching videos is not enough.
Yeah.
It's not enough.
Yeah, I know. It is. This is the one thing that it should be. If there is one thing that should be practiced, this is. It is a unit test.
Yes, absolutely. So go back to the lectures there. Pay attention, take notes, and practice what you see there.
Yeah.
Nothing is by chance there. We create the curriculum to teach you the step by step and show you all the techniques. But just watching is not enough. It's just like watching someone swimming. You're not going to learn how to swim until you actually jump in the water.
Yeah.
Because there are invisible forces around you that you cannot see in a video, like when you're riding a bike. Like, there are invisible forces like gravity. You don't see it. Only when you actually experience it, you know what's going on. And that's why you need to go through this loop. And when you get stuck with the practice, go back to the concepts, see more examples, and keep repeating. And of course, ask questions in the academy and in the community.
Absolutely.
Make sense?
Yeah, makes sense.
Awesome.
Any other questions?
No, thank you.
Yeah.
Awesome.
Thank you for joining us, Ali.
Thank you.
Thank you.
Bye. Take care.
Bye-bye.
Bye.
Bye-bye.